Hello, thanks for joining the Layer 1 to 3 World Congress. My name is Vadim. I'm a network architect of PJC MTS, Tier 1 Russian ISP. Today I would like to tell you about our experience of implementing automation in an ISP's network. We will discuss the tasks that our team solves, about the difficulties that we face during implementation, and I will tell you about current solutions and new processes for the ISP related to the network automation. Our network contains Huawei, Cisco, Juniper, Coriant, Nokia devices and their main device types. Also, we have a various protocol stack. Our main goal is to implement the service automation. By service, I mean the automatization of business processes in order to provide customers with a network connectivity, for example, connecting B2B customers. In order to implement the service automation, we need to go through some stages. The first stage is standardization of network designs. It is hard and very important stage because the automation always needs an up-to-date version of network documentation. The second stage is automated network audit. Before applying the configuration automatically, you need to learn how to read the configuration of the network devices and compare it with the reference templates. The third stage is network migrations following the design template. The first stage is automated testing, because any changes in designs, policies, templates should be automatically tested in the laboratory. Semi-automatic changes in the network. Before deploying automation, it is necessary to make semi-automatic changes within the production network to avoid errors and mistakes. And of course, you need internal system integration, because most likely the provider has legacy systems for network maintenance, so it is necessary to integrate with these systems. And once all stages are completed, we are ready to start to automate services. So let's consider the general architecture of the solution. We have distinguished four general layers. Layer 1 is a network layer that contains network equipment and services. The network team is responsible for this layer. Layer 2 is orchestration layer, which provides information about the network, controls configuration changes in a network, is responsible for network services such as VRF, pseudowire, VPLS, and etc. Also, this layer provides APIs for the upstream systems. The orchestrator vendor is responsible for the orchestrated components and the development of the network services. The network automation team is responsible for testing and deploying services into the production network. Layer 3 is ISP systems, which is the foundation for automation, because it is responsible for processing network automation and managing network resources. Now we are developing systems in this layer ourselves, and it includes various systems. Gold config is a master system of reference templates, and it is system for storing and testing templates, and it is database with variables for generating configuration. NPM is a system for collecting and processing network performance data. NetworkDB is a database with the current device configuration. IPAM is an IP address management system. Doc Center is service for storing and displaying up-to-date documentation about the network. It is rules, algorithms used in the network, designs, templates, and schemes. Layer 4 is service engine. The layer is responsible for the logic of the service. It includes front end, which is responsible for interacting with the users and the service administrators, backend, which is responsible for integrating with the other systems that form the service logic. The service engine implements additional functionality, such as user authorization and authentication, logging of actions, implementation of security requirements, and it also responsible for the service workflow. These slides highlight the participation of different teams managing different components. When you have decided to automate your network, you need to understand that it will change the workflow in the company, and you will need the team to maintain the network automation. And in my opinion, this team should be in the ISP. And it's very important to create high-level communication between different teams in order to support the network automation. That's why I would like to highlight a new process for telecom operator. there is necessity to build processes of development, testing, and implementation changes. Therefore, we ought to have several types of areas. Development areas, where developers' teams develop new functionality and fix bugs. Testing area, where the builds need to be tested. Production area, the most crucial stage where we apply the updates to the real network. ISP should have software development tools for collaboration with developers' teams. This new process requires software development skills in the operator and network vendors. Now we are testing this process with the company together with two vendors. And the first thing, we started to build the process of documentation development. We are faced with the fact that it's extremely difficult to keep the documentation up to date, to control and to agree upon its changes. So we have decided to switch to Markdown for documentation and Jinja 2 for templates. For vendor, we created our own project in GitLab where the developers make changes, and then these changes are coordinated with various departments using a merge request. The master branch of the project is automatically pulled into Doc Center and GoldConfig, where it is available for users. Thus, we want to satisfy the following requirements for documentation. Documentation update. All employees working with the network can receive the latest version centrally. Documentation change control. We can control what, when, by whom, and where changes have been added using machine-readable formats. Unfortunately, over the time, it is extremely difficult to check changes in multi-page documents, so we are trying to switch to Markdown. Centralized data source. The use of GitLab as VCS and Markdown format allow us to organize the process in such a way as to have a website with the up-to-date documentation. Ability to work with multiple developers on documentation. The current process allows multiple development teams to work on documentation. Management of documentation access. Differentiation by project in GitLab allow you to manage access for vendors. As I mentioned earlier, we need to check what is happening on the network. Therefore, our focus is to report design discrepancies. In order to do it, we have begun to collect information about the network from various sources and put it into database. We are currently running a full-fledged project on the Django Python framework with a Postgres database to collect the complete information about the network. The main blocks are presented on the screen. This is the information about devices, cards, software, ports, interfaces, services, scaling parameters, protocols, and etc. The trick is that we immediately began to implement common data models for several vendors such as Huawei, Nokia, Juniper, Cisco. Therefore, we can apply common algorithms regardless of the vendor, and it is also simplifies further work in general. You can tell me that is an inventory system that is implemented in many control systems and open source projects. Yes and no. Yes, this is inventory system. However, it is multi-vendor out of the box, and now it supports 5 network vendors and 3 radio relay vendors. It implements our internal needs for data processing and reporting. It is integrated with our main systems in the company. Since we are developing it, then we can easily add to change functionality in it. This system is one of the key components for future automation in our network. I said before that we are developing a template management system named GoldConfig. Configuration templates are stored in the GoldConfig system. The slide shows the process of generating a configuration. First, we need to prepare the initial data. It can be formed on a website, a REST request, or something else. For example, to generate a complete template for device, I need 7 parameters: region, vendor, device type, software, hostname, loopback, and NNI interfaces. I pass these parameters to the generator, which makes a request to the gold config database, which stores the parameters of region, protocols, network, and etc. The generator generates a dataset with all parameters, and it is passed to the render of the Ginger2 template, from which the final configuration is obtained, which we can send to Autotest or provide to the user. When operating templates, there is a problem of maintaining variables. They need to be unified between vendors. Therefore, we standardize variables in databases and generator. The slide shows an example of how to hostname variable is written in dataset and how it is written on different vendors. It makes it much easier to exploit templates. Another problem with templating is template variability. You should be able to select a template depending on network type, hardware manufacturer, device type, device software version. And we solve this problem by storing templates in GitLab and routing them to desired template for a generator or API. The storage of variables is built on the principle of the links. Each variable can be referred to network type, vendor, device type, software version. And the slide shows an example of storing ISIS global variables for Huawei devices and MBH network type. Pay attention on the description field. It used to link with other systems, including NetworkDB for automatic network check. Thus, we implement a standardized approach to the configuration variables. Forming a master system for storing variables, we do not put a lot of complex logic in configuration templates. We avoid hardcore variables in other systems. We provide storage of variables at different levels: region, vendor, network, and etc. We implementing a service for generating configuration and for its automatic testing. Everything that I talked about earlier is successfully used today to achieve the service automation. In our case, this is auto-integration of the node into network. The device is put into the rack, power and wires are connected, and then magic happens and the node automatically connected to the network. In order to perform it, you need to go through several stages: site planning, reconfiguration an existing network, installation and switching of new equipment, automated configuration of new device node, network reconfiguration, and tests. And let's take a closer look at this process. Site planning. It is necessary to select several parameters to install the device. It is region, vendor, hardware type, software, hostname, loopback, and NNI interfaces, just like for generating a configuration. At this stage, it is also necessary to automatically get free ports in the node into which we will include a new device, as well as automatically obtain IP addresses. Next, we need to form a request to orchestrator, which will make a request to goldconfig, receive the required variables, and preconfigure the network. Configure UNI, it is VRF plus DHCP relay. After that, we will wait for our node, periodically checking whether it has appeared. After connection, a new device, the orchestrator will configure a new node, then existing one, and after that, ISBRs and road reflectors. The orchestrator is testing network, and after that, node is successfully turned on. At the moment, we have tested this workflow in laboratory, and we are preparing for implementation in the productive network. We are planning implementation in this fourth quarter of this year. In conclusion, I want to say to implement the automation service, we have created several additional services: documentation center, gold config, NetworkDB. And now we are ready to implement several cases, and I hope that I will have the opportunity to tell you about them in the future. Thank you for your attention. Do you have any questions?